Okay, so in this case, we're graphing exponential curves, so they're not linear anymore. Why do we call these curves or these functions exponential? What's special about them?
Variable. Exponent is variable.
The exponent is variable. Okay, you see how it's an exponent? It's to the power. Okay, so it's not 2x, 2 to the power of x. Okay, so when your exponent is a variable, we call that exponential. Okay, we are going to have a whole also like what is it called? A unit that we're going to talk about exponential. So let's look at the values that we're going to pick for x. So what do you think we're going to pick for x here? So 0, 0, 1, 2. Okay. So 0, 1, 2. We can't use 3. Okay. So y equals 2 to the power of 0. I want you, if you know what the answer is, you can shout it to me. But if you don't, I want you to put it on a calculator.
The whole lesson about this.
We had a whole lesson about it. They did 11C with me. That's why they know the answer. 2 to the power of 0. 1. Yeah. If you look here, anything to the power of 0 is 1. Okay. Okay. Now, 2 to the power of 1. What does it mean when we're talking about power? How many times is it multiplied by itself, right? So 2 to the power of 1 is like 2 by itself.
Yeah.
How about 2 to the power of 2? 4, right? 2 times 2 is 4. How about 2 to the power of 3?
6,
8. Right? Because 2 times 2 is 4. Times 2 is 8. Okay? Common mistake. It's okay. Happens all the time. So what are my points? So my points are 0, 1, 1, 2, 1, 2,
2, 4,
2, 4,
3 and 8.
Let's see if my 11C's still remember this. What if I have negative 1 as in my x value?
So 2 over, it's a 2.
Say, what is it? So 2 to the power of
1 over
I
1.
just flipped
1
it.
over 2.
I just flipped it. 1
Okay.
over 2 and to the power of 1.
That's right. If we have a negative exponent, we flip the base. Flip the base.
The easiest
So,
lesson.
I'm going to show you this. So this is what I have. Negative exponent, right? You see that? So to change it to a positive exponent, I have to flip the base. So the base is 2 over 1, right? A whole number has a division by 1. So if I flip it, it becomes 1 over 2 to the power of a positive 1. Okay? So it makes your power positive when you flip the base. Okay? So if you look back here, we have, where is it? Right here. A to the power of negative m. You flip it, and you make the exponent positive. So if I have a negative 1, it's the same thing as writing 1 over 2. So your point is going to be negative 1/2. Okay? I'm just going to do these points so you see how my ends of my graph is going to look like. What if I have a negative 2? So y equals 2 to the power of negative 2. So 1 over 2 to the power of 2, which is 1 over 4. Okay? So it's getting smaller and smaller. So this is going to be a half, this is going to be a quarter. So let's try to graph this. So, if I I have a -2, it's a quarter. So -2 is right here, and a quarter is right here. Okay? So this is 1, 2, 3, 4. -1 is a half, so it's right here. What was the value of y at 0? No,
Sorry,
1. What was the value of y at 1? At 2? At 3? So, one, 2, 2, 4, 3, 8.
Why did we solve for that negative?
Because I want to show you how the end of the graph's gonna look like. You'll see why when we graph. Okay? So, if I didn't solve for it, I'm gonna have something that looks like this.
Yeah.
Right? But what happens in the negatives, this kind of tells me exactly what's happening. You see how this is going like this? Right? So it kind of tells me that it's gonna flat out. Right? If I do -3, you're gonna see that's gonna be 1/8. Okay? So it's gonna still be positive. It's still gonna be like on top of the x-axis, but it's gonna get near that 0 line. It's gonna flat out. Okay? So this graph is never going to touch that blue line. It's gonna get close to it. 1/8 is like 0.000 whatever, right? It's gonna be, what's 1/8? Is 0.125, sorry, right? So 0.125, which is very close to 0, but it's never gonna touch that 0. Okay? So the reason why I did the negative is to show you what's gonna happen on the negative side. Okay? So, if you look at this graph, this is called an exponential graph. It's an exponential growth, right? If I'm moving to the right, it's gonna start slow, but then it's gonna increase fast, rapidly increase. Okay? Guess what? At 4, it's going to be 16. At 5, it's going to be 32. At 6, it's going to be 64. So you'll see that as I'm going up the x values, my y values are going to grow fast. Okay? That's why we call this exponential. Are you guys okay with this? Okay. What do you think? What kind of x values I should pick for this function?
It's a decay.
So bring 0 to
Should be.
That's decay.
Because it's
Okay.
0.5.
I'm gonna choose
So what values of x do you think I should pick?
0
2.
to even numbers.
Start from 2, 4, 6.
Remember, I am not multiplying. Remember, I'm not doing a half times 2. I'm doing a half to the power of 2. If I pick half to the power of 2, what am I going to get?
1. No.
What's a half to the power of 2? 1 over 4,
Yeah.
right? What if I pick a half to the power of 3? What am I going to get?
1 over 9.
What if I pick 1 half to the power of 4? Can I graph these numbers?
No.
Are these easy numbers to graph? So if I pick 1, 2, 3, 4, right? My numbers are going to be very tricky to graph. I won't be able to graph them properly. What other values of x do you think I should pick?
Points?
No, even no, 2, 4.
No.
Just that number.
Never. Even numbers.
Should
What do I get? What do I get?
Yeah.
Oh, we're flipping.
We're flipping. So when I flip the base, what does it become?
Okay.
2. 2 to the power of 1 is 2. Yeah? So if I pick negative numbers, now I flip my base. So my base become a whole number. Right? So when you have bases of between 0 and 1, you want to pick negative numbers. So this is when you are what we call math literate, because you know what values to pick. Okay? Because if you pick the other values, you're gonna have hell of time trying to graph this. Okay? So let's pick some negative numbers. So we're gonna go from negative what? 3?
Negative 1?
So we're gonna start negative 3, negative 2, negative 1, 0. We can get 1 and 2. Okay. So if I put 1/2 the power of negative 3, it's the same thing as writing what?
1 over 2 to the power of 3.
2
is
over 1, you mean?
Yeah. 2 over 1, sorry.
Right? Same thing as writing this, because I flipped my base and I made my exponent positive, which is equal to 8. So same thing as writing 2 to the power of 2, which is 4. To the power of 1, which is 2. What's a half to the power of 0? It's 1. No matter what the number is, it could be a letter. Even an x to the power of 0 is 1. 1,000 to the power of 0 is 1. If I have a half to the power of 1, that's a half. And a half to the power of 2, that's a quarter. Okay? So my points are the following. Negative 3, 8. Negative 2, 4. Negative 1, 2. 0, 1. 1/2. And 2, 4. I know it says to graph them on separate axes, but because I don't have too much room, I'm gonna actually graph them on this. And then nice to compare, okay? I want you to see the difference. So, the first point I had was negative 3, 8, right? Negative 2, 4. Negative 1, 2. 0, 1. 1, 1/2, 2, quarter. So my graph is gonna be like this. Right? Can you guys explain the difference between the two? What do you see?
Going from the left side to the right.
One is increasing, one is decaying.
Decreasing and decaying is the same thing. Increasing. One is decreasing, the other is increasing.
Decreasing.
Is it growth and
Sorry.
growth are in one health?
Do you see that they meet at a certain point?
Yeah.
What is it?
1.
0, 1.
No,
0.
1, 2, 4, and
Right? 0, 1 is where it is. Right? Because anything to the power of 0,
What?
okay. I'm gonna stop this.